If you think trains are just steel boxes on wheels, you haven't seen what rail engineers were willing to risk. From jet engines to spinning propellers and glass-walled cabs, you're about to meet the strangest locomotives ever built. This is 10 weirdest locomotives ever made. Germany, 1931. The future didn't sound like pistons, it sounded like wind. The Schienenzeppelin looked less like a train and more like a flying machine that had lost its wings. Built from aluminum and shaped like an airship, it was driven by a massive wooden propeller mounted at the rear, spinning freely in open air. Instead of pushing steam through pistons, it pushed air, turning the entire locomotive into something closer to an aircraft than a rail vehicle. When it accelerated, it didn't chug or rumble, it howled. In June 1931, it reached 230 kilometers per hour, setting a rail speed record that would stand for decades. But the truly strange part was not how fast it went, but how little it could do. The spinning propeller made stations dangerous. Loose debris could become deadly projectiles, and it couldn't pull a single passenger carriage. It could only move itself. The Schienenzeppelin proved that steel rails could handle extreme speed. But it also proved that speed alone is not enough to build a working railway. Without safety, hauling ability, or flexibility, even the fastest train has no future. Still, the idea it planted was dangerous and powerful, because if a propeller could push a train that fast, engineers soon wondered what would happen if they tried something even more extreme. Moving from propellers to pure jet power, American engineers took the next wild leap. In 1966, the New York Central Railroad took a Budd RDC railcar and bolted 2 jet engines onto its roof. They didn't streamline them. They didn't hide them. They simply mounted them like rockets and sent the car down the track. They called it the M497, better known as the Black Beetle. On a test run, it reached 183 miles per hour, making it the fastest rail vehicle ever recorded in the United States. It didn't sound like a train. It sounded like a military aircraft tearing through the countryside on steel rails. The goal was not to carry passengers, but to test what the tracks themselves could survive. And the result shocked everyone. The rails stayed intact. The wheels stayed on the track. The experiment proved that conventional American rail infrastructure was far stronger than anyone had believed. But like the Schienenzeppelin, the Black Beetle was never meant to be practical. Jets were too dangerous, too loud, and too inefficient for real service. Still, it permanently changed how engineers thought about speed. And once speed was no longer the limit, railroads began chasing something else entirely. Modern image. Moving from raw speed to pure style, the 1950s brought a different kind of weirdness. Railroads were losing passengers to highways and airplanes, so they wanted trains that looked futuristic. General Motors responded with the Aerotrain, a sleek diesel locomotive pulling passenger cars built from actual highway bus bodies. Real buses, mounted on rail wheels and wrapped in shiny silver shells. From a distance, it looked like tomorrow. Up close, it was a compromise on wheels. The lightweight bus bodies made the train rough and unstable at speed. Passengers complained about the ride. Crews disliked how it handled. What looked streamlined was actually uncomfortable and impractical for long-distance travel. Only 2 Aerotrains were ever built, and both were quietly withdrawn from service. But the Aerotrain is strange for a deeper reason. It shows how desperate railroads had become to look modern, even if it meant borrowing designs from the highway and forcing them onto rails. It was not built to be the best train. It was built to look like the future. And once railroads started chasing image instead of function, locomotive design was about to get much stranger. Next, engineers decided that if one engine was not enough, they would simply build 3. In 1914, the Erie Railroad created the Triplex, a steam locomotive designed to pull almost impossible amounts of weight. Its 2-8-8-8 wheel arrangement gave it 3 separate sets of powered driving wheels, including one mounted under the tender itself. On paper, it was one of the most powerful steam locomotives ever built. In practice, it behaved very strangely. The rear set of wheels only received power when the locomotive was under heavy load. As soon as speed increased, steam demand dropped, and the rear engine lost power. That meant it was strongest when barely moving and weaker when it needed to accelerate. It was a brute built to start trains, not run them. The Triplex could move enormous loads, but it struggled to keep them rolling and tore up track in the process. And when pistons started reaching their limits, engineers began looking for an entirely different way to make power. Moving from raw pulling force to extreme speed, the Pennsylvania Railroad pushed steam to its absolute limits. Built in 1939, the PRRS-1 was the largest passenger steam locomotive ever created. Its massive 6446 wheel arrangement stretched longer than many station platforms, wrapped in sleek Art Deco streamlining like something from the future. On straight track, it was spectacular. The S1 could run over 100 miles per hour while hauling long passenger trains with ease. But railroads are not built from straight lines. The S1 struggled on curves, wore out track, and was difficult to handle in yards. Only a small portion of the PRR network could even support it. There was never a second S1, and it was scrapped in 1949. It proved steam could still be spectacular, but not practical at that size. So instead of building bigger pistons, engineers tried replacing them altogether, which brings us to our next on list. Moving beyond pistons, the Pennsylvania Railroad turned to turbines. In 1944, they built the S2, a steam turbine locomotive that used a high-speed turbine and reduction gears instead of traditional rods and cylinders. At speed, it was smooth, quiet, and incredibly powerful, more like a jet engine than a steam locomotive. But turbines have a fatal flaw. At low speed, they are extremely inefficient. The S2 burned huge amounts of coal while idling in stations or creeping through yards. Gearboxes overheated, and maintenance was complex. Crews loved it on the main line, but dreaded working with it anywhere else. The S2 wasn't unreliable, it was impractical for daily railroading. When diesel-electric locomotives arrived offering smooth power without these problems, the turbine experiment quickly died. And with that, steam's wildest reinventions were coming to an end. Moving from turbines back to raw steam, British engineers decided to chase power in a far more dangerous way. In 1929, the London and Northeastern Railway built a locomotive nicknamed Hush Hush, officially known as the W1. Instead of using a traditional firebox and boiler, it relied on a high-pressure water tube boiler, similar to what was used in ships and power stations. The theory was simple. Higher pressure meant more power and better efficiency. The reality was terrifying. The water tube system was complex, fragile, and extremely difficult to maintain. Leaks were common. Pressure spikes were unpredictable. Crews feared it because if something failed, it could fail violently. The locomotive did run and even reached impressive speeds, but the risks were too great and the upkeep too demanding. Eventually, the experimental boiler was removed, and the W1 was rebuilt into a conventional steam locomotive just to make it usable. The W1 did not fail because it lacked power. It failed because it pushed steam beyond what was safe. And once engineers saw the danger of extreme pressure, some began looking for mechanical solutions instead. Moving away from boilers and pressure, British engineers tried something completely different. In 1908, the Midland Railway built the Paget locomotive, a machine that abandoned traditional connecting rods entirely. Instead, it used bevel gears and rotating shafts to transfer power from the cylinders to the wheels. The idea was to reduce vibration, eliminate hammer blow, and allow smoother high-speed running. On paper, it was brilliant. In practice, it was a disaster. The gears overheated, lubrication failed, wear rates were extreme. Even experienced engineers struggled to keep it running for more than short periods. Diagnosing faults was incredibly difficult, and maintenance crews quickly grew frustrated. The locomotive barely entered service before being withdrawn and quietly scrapped. It wasn't a foolish concept. It was simply too far ahead of the materials and lubrication technology of the time. The Paget locomotive was a machine from the future, built with the limitations of the past. And while some experiments chased complexity, others tried to solve an entirely different problem. Long before electric trains, London faced a dangerous problem. Steam locomotives filled underground tunnels with smoke and poisonous fumes. To solve this, engineer John Fowler built a locomotive in 1861 that carried no burning fire at all. Instead, it stored heat in thousands of fire bricks, releasing steam as they slowly cooled. It became known as Fowler's Ghost. At first, it worked. Trains could run through tunnels without choking passengers. No smoke, no flames. The air was breathable, and underground rail travel suddenly seemed possible. But heat fades. As the fire bricks cooled, steam pressure dropped. Power disappeared. Trains slowed or stalled. Crews had to constantly return to reheat the bricks, making service unreliable. The idea was brilliant. The endurance was not. Fowler's Ghost helped launch the world's first underground railway, but it could never survive as a long-term solution. And that strange stepping stone would lead to one final, very unusual design. To end the list, we move away from raw power and into something far more visually strange. In the early 1900s, the Royal Bavarian State Railways needed a small locomotive for lightly used rural branch lines. Their answer was the Bavarian PTL 2/2, better known by its nickname, the Glaskasten, meaning glass box. The name made perfect sense the moment you saw it. The driver sat inside a cab almost completely wrapped in glass, built directly around the boiler. From the outside, it looked like a steam engine wearing a greenhouse. The idea was to give the driver maximum visibility on narrow, twisting countryside routes where animals, carts, and people could appear without warning. And it worked. The Glaskasten was easy to drive, economical, and perfect for branch line service. But it was also brutally uncomfortable. Heat from the boiler flooded the glass cab. In summer, crews baked. In winter, condensation covered the windows. It was practical. It was efficient. It was completely bizarre. No other locomotive put its crew inside a transparent box wrapped around a furnace. And that's what earns the Glaskasten its place among the weirdest locomotives ever built. So, if you enjoyed diving into the wildest experiments ever put on rails, hit like and subscribe for more stories about machines that pushed engineering to its limits. From forgotten failures to unlikely successes, we uncover the ideas that shape transport history. Tell us in the comments which locomotive shocked you the most.